So, we are starting with this 1 over 4. So we want to convert our fractions into a decimal. I think maybe you haven't done this since elementary school, or did you do this last year? You touched on it. So this probably also depends on which quarter you had math in and all that stuff. So, how we would do this, well, first of all, I've purposely chosen a number that I think you probably know the answer to just by looking at it. Do you know the answer to this? What is it? Yeah, I heard 25% and I heard 0.25. Good. So let's look at how to get that 0.25. How we would get that 0.25 is we take this number at the bottom and we are going to write it outside, and we're going to take this top number, the numerator, and we're going to put that on the inside in our division statement. The thing is, 4 doesn't go into 1, right? So what can I do in order to be able to work with this? Instead of 1, what can I do there? I can add something to it. What could I put there? Put a 0 there. Good. So 0.0, and at the top I'm going to put a 0 there as well, right? So now we can look at this and say, how many times does 4 go into 10? Twice. So we put a 2 up here. I'm not quite done yet. What would be my next move? 4 times 2. So we're going to multiply this, and we get 8 when we do that. And then we subtract these, and what do I get? I get a 2. So again, 4 doesn't go into 2. So what's our move whenever we run into that problem? We just throw another 0 because we're not actually changing anything. 1.00 is the same thing as 1, right? So we're allowed to do that. And now I could say, well, how many times does 4 go into 20? And do you see how we get the 0.25 now?
That was easy.
Good? Yeah, question?
Yeah, I just want to ask, why don't you remember the
Oh, because they won't all be like this. So we need to have those skills, right? So we're practicing the skill, but I chose a number you know the answer to, so your mind can pick up on how to come up with that 0.25 instead of just saying 0.25. Does that make sense? Yeah, so we're practicing the skill. Harry? What do you mean? Well, what happens? Stay tuned. I'm going to show you examples where you can't just do this. Yes? Yeah, we'll get to that too. Good? So on to the next one. What if we have the decimal already and we want to convert that into a fraction? No problem. We want to convert this into a fraction. In our fraction, what can I put as my denominator if I have 0.25 and I'm wanting to change it? 100. Because I take this decimal and I move it over 2 places to get 25 to a whole number. Does that make sense? So I'd put 25 at the top, and then I know that I have 2 zeros here because I moved it over 2 decimal places. Are we good with that so far? Okay, so that's good. We did change it to a fraction, but we never want to leave our fraction in this form. Whenever possible, we want to shrink it down or reduce it. And the way to do that is to look for the largest number that goes into the top and the bottom. What would that be in this case? 25. So if I divide by 25, top and bottom, what do I end up getting? 1 over 4, which is the number we had originally started with.
That was easy.
Good. What if I didn't, my mind was tired, I didn't think of dividing by 25. What if I first divided by 5 here instead of 25? Then what would I have gotten? 5 over 20, right? And then I would take it another step to divide it out again. So it would just take more work if I didn't pick the largest number to divide by, but I could still do it. Are we good with that so far? Let's try another one. What if we have something like this and we want to convert this into a fraction? So when we go to pick our denominator, what should the denominator be? 1,000. Does that make sense to everybody? 1,000, because I moved it over 1, 2, 3 decimal places, so that's how I know I have 1, 2, 3 zeros. Do you see that thought process? And then what goes at the top? 222. I chose that because of the date. Are we done? These numbers aren't quite as easy to work with, but we're always looking to simplify it if we can. So can we simplify these two? What number goes into both of them? So divide this by 2 and divide this by 2. So what do we get at the top when we do that?
111 over 500.
111 over 500. Can that be reduced? Can 111 be divided by anything?
Yeah, it could be divided by 3.
Can the 500 be divided by the same number?
I think it could be divided by 3, but 500 is not.
So then we can leave it in this form. Good?
Yeah.
Having fun yet? Okay. Then we come across something like this. We want to add a bunch of fractions together. Do you like fractions? Wait, earlier I had one person who said yes and now they didn't say yes. Oh, you do? Okay, good. Still have one. That's good. 1 out of 30, I'll take it. It's more than usual. Okay, 2. We have 2. 3. Oh, good. 4. There's more. Good. The thing is, when you have fractions with different denominators, what do we have to do in order to be able to add them together? At the back there, what's your name? Make the denominator the same, right? This is the key to math and the key to life. Look for similarities and it solves so many problems, right? So what is a number that's common to this, this, and this? 12. So we want to change all these fractions to make it so that the bottom is 12. So in this first one, are you ready for the next lesson? I'm going to teach you in this class how to live in denial. Everybody good with that? Just temporarily, and then you have to come back to reality. So this is us living in denial. We're going to pretend the rest of it doesn't even exist. How do I change this fraction into a denominator of 12? What do I need to multiply by? Yes? Multiply by 6, and you got to do it to the top and the bottom. So what do I end up getting? Instead of 1 over 2, it's
6 over 12.
good. So we're done with that one. Okay, so we were living in denial. We're bringing back a little bit of reality because we're ready for it, but not all of it. That's getting ridiculous. Let's just deal with that. And what do we multiply this by? Oh, that's the wrong color. How could I do that? Multiply this by 3 over 3. Everybody good with that? And what do we end up getting? 9 over 12, so we're done with that one. Doesn't it just feel good to give yourself check marks? Okay, do it. Go ahead, give yourself any check marks you want. Now we are fully into reality. What do we multiply this by? 4 over 4. Everybody good with that? And what do we end up getting? Plus 8 over 12. So far so good? Okay, so now let's bring in this nice colorful math. What's the denominator going to be in the answer? Going to be 12, so we're good with that. What's 6 plus 9? That's 15. What's 15 plus 8? 23. Is everybody good with that? Do we like our answer looking like that? What's wrong with it? Good. Numerator is bigger than the denominator. I actually don't know. Did you learn how to deal with this or what to do with this? Okay, what do we do with this? divide them. So 12 into 23. Is everybody good with that? How many times does 12 go into 23? Once. So then we multiply this out, and we would get this here. And when we subtract, what do we end up getting? 11? Everybody good with that? Make sense? And so what does that tell us? So I still, I don't know. How do I do this? I go back to here. Oh, that's the wrong color. How could I do that? Equals, how do I take this and convert it into something that makes sense to me? Remind me of your name? Matthew? Yeah, so 1 is the whole number. So this is the same thing as 1. And what's the denominator again? The denominator is going to be 12, and at the top is the 11 that was down here. So that would be our answer.
That was easy.
Good?